I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, January 31st. Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype. Looking at significant wave heights for the North Pacific Ocean, we see remnants of a gale that was in the northern Gulf, produced some reasonable seas with swell pushing towards northern California, and a new system is developing off the Kuril Islands, not producing giant seas, but it is supposed to traverse most of the Pacific and end up north of Hawaii, producing raw swell there. So there is hope for the moment. Let's get into the details. As usual, we'll start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they form, help direct their track. We're looking for a trough right here, a dip in the jet. You can see right there. And that flow creates a counterclockwise flow aloft and down at the ocean surface. That's what low pressure looks like. And low pressure, if it's deep enough, generates winds. Winds, if they're strong enough, generate seas. Seas, as they radiate away from the fetch area, turn into swell. Of course, swell, when it hits your beach, turns into surf. So we have a trough right there. We also have a trough right here. So two troughs to look at, but the opposite of a trough is a ridge, and we have a massive ridge right here. And what that helps do is create high pressure aloft and at the ocean surface. That does nothing for generating swell. So we have this kind of strange pattern where a trough in the west, trough in the east, massive ridge of high pressure in the middle. You'll notice the jet is pushing off Japan, 190 knot winds. That's pretty strong. Makes it to the dateline, 180 west, right there, and instantly splits with the northern branch racing north and the southern branch racing south. And then at some point, the jet decides to fall back south, creating this trough off of, we'll say, Vancouver Island. And that supports low pressure there as well. And then pieces of the southern branch actually radiate back to the north and flow into the U.S., and the rest of it falls down to the equator. So pretty weird kind of pattern here, blocking pattern right here on the dateline. The jet hits it just, it's like hitting a brick wall, and it splits, heads any way it can to get around it. All right, so we go into Monday, much the same pattern. The trough makes it a little bit further east. This trough sort of hangs on. Not particularly good. In fact, by Tuesday, the trough here off the U.S. West Coast gets what they call pinched. Very little area there. Makes it hard for a broad low-pressure system to start circulating. Pretty much cuts off swell production. Same thing kind of starts happening here just over the dateline. We get into Wednesday. More of the same deal. The trough off the U.S. West Coast, all but gone. Energy pushing down the West Coast. This becomes our weather event, and probably the final weather event for California for a while. And the trough that was up here, notice Hawaii's right there, the apex, the bottom of the trough, coming very close to the islands. Notice also the jet falling directly over Hawaii on Wednesday. And as we get into Thursday, more of the same thing. The apex of the jet just a hair bit east of the islands. Most of the jet's energy right over Hawaii. Weather event there for sure. The trough all but gone. No trough in the U.S. High pressure starting to move towards California. That suggests high and dry conditions again for the state. The last little bit of rain, at least for a little while. We get into Friday. Maybe a hint of a new trough trying to develop. The whole jet just boom, racing right over Hawaii there. How you like those sound effects? And then Saturday, everything pretty much stabilizes. The jet actually makes, you can see it's holding to about 170 west, and it starts splitting right in here somewhat, but oh, no, it gaps there. I was going to say it's trying to make it into the Gulf, but it can't quite do it. And then we get into, where are we? Sunday, and we'll just go, there we are, 180 hours out. Really just a convoluted mess in the East Pacific. The brick wall holds steady on the dateline right here. Good energy pushing off Japan, just not enough of it, not enough momentum to break the grip of high pressure that has a just tightly gripped on the Gulf of Alaska. And that's what we really want to see, is this thing open up and get a big trough running through here to support gale development, at least give us rain if we're not going to have surf, but not so much a great pattern aloft. Let's go take a look down at the surface. Here we are, surface level wind, surface level pressure. All right, so here's the last little remnants of a gale that was in the Gulf. We'll look back at the wave model here in a minute and see what happened with this one. But it has generated some swell. It's hitting the outer buoys off of Northern California. Nothing huge, but, yeah, swell. But it's probably going to be marred by south winds everywhere from, at least Big Sur northward. Also, new system pushing off, we'll say the Kuril Islands right there. There's Japan, Kuril Islands, Kamchatka right up there. 35-knot winds, broad fetch of 30-knot winds, aimed at Hawaii. It'll generate some swell, but nothing particularly impressive. As we get into Monday, system a little bit better organized, moving north, 40-knot winds pushing off Kamchatka. Nothing in the east, high pressure in control, no big surprise there. Another system tries to pull off Japan as we get into Tuesday, but notice all this fetch is aimed north. This is what remains here. And remember, there's a trough right here building north of Hawaii, and the jet's going to start pushing over Hawaii. So you see 30, 35-knot winds aimed at Hawaii. That'll generate some fetch, local swell. Winds looks like are supposed to be from the south over the islands on Wednesday. Then you see the front starting to move in. Looks like a Kona wind event, northwest winds. Still some fetch hanging there. Everything over here in the Northwest Pacific goes to sleep. High pressure building, 1032 millibars. Smells like a wind event for midweek or later in the week for California. Another gale tries to wind up here off Kamchatka on Thursday night. We'll see what that does. Building, with 55-knot winds, that makes it a storm. Anything over 50 knots is a storm. Will it make any eastward progress? And we already know the answer, right? And you kind of do too, given the split jet and everything. Yep, starts lifting northeast, heading for the Bering Sea. Probably enough to generate some background swell. And it's gone as we get into Saturday for the most part. We're looking here, seeing what's going on up under the Aleutian Islands. Not really much at all. Another system on Sunday trying to develop. Let's see, we'll go 180 hours out. There we go. The suspicion, given what we saw in the jet at this point in time, was coming off here, splitting again. This will be bound for the Bering Sea as well, with high pressure or some flavor of it locked in control over the East Pacific. All right, let's go take a look at the wave models. So we're going back in time. We're going back almost a week ago, Monday, because a gale developed off Japan. Nothing particularly impressive, and you can see it built some seas, and while lifting like all the others hard north, it got right here, 55-foot seas, but most of those were north, but there were some seas right in here. The point being, swell from this system is hitting California. It started yesterday afternoon, Northern California. Today, there were waves, head high, a little bit overhead, some pretty long lines, pretty good form if you're at the right place at the right tide with the right wind and all that kind of stuff. It was fun and rideable, nothing epic, but certainly better than not surfing at all. But I tell you, it is kind of hard to go from it being 20 to 30 foot every day to head high. But the flip side is, if you don't want to ride death surf, then maybe where we're at is a good place. Certainly, it's a lot safer. All right, so anyway, then this system disappeared. Swell is supposed to continue into tomorrow. What's tomorrow? Monday. But now remnants of this system, ignore what was happening over here because that swell's already gone. Started developing on Friday here in the Northern Gulf with 27-foot seas, falling southeast on Saturday. That was yesterday. And then dissipating this morning. Swell from this system expected in, I think it's Tuesday, Wednesday kind of thing. Pretty big, pretty raw, pretty ugly with south winds and some rain and all that kind of stuff, at least north of Point Conception, even Southern California. We'll take a look in a minute, see whether they get any rain or weather out of this, but I think most of it's confined to north of Point Conception. And then our new system developing off of Japan. All right, let's go take a look at the forecast now. Right, so this is the wave model, and just a reminder, this is a model of a model. It takes winds, I think it's a GFS, or it might be winds from another model, and then uses that as its input to then model the effect of those winds on the ocean surface and calculate sea heights from that and swell period and all the rest of it. So it's a model of a model. It is not the ground truth. Well, the 00 hour is the best analysis that you can say, here's what's actually happening at this moment in time. But as soon as you go to the 6-hour forecast, it's a projection. It doesn't mean anything unless it actually verifies. The previous slide we looked at, we'll go back here just a second. Previous slide we looked at, notice every one of these are hindcasts. We take the hindcast from every 6-hour run of the model and stitch them together. So you get a pretty good view of what the best estimates of what actually happened. The only way you can do better is the satellite passes, and we have altimetry on the site you can access and look at it that way. But the 00 hindcast is a pretty good baseline for knowing what's going on. The model, they regularly compare the model to the satellite altimetry data to verify that the model's doing good. They tweak the model fairly regularly too to try to get it even more accurate. So, the models have come a long way in the past 20 years or so. How long has it been? 25 years since we've been publicly doing this. So, things are a lot better than they used to be back in the old days. All right, moving on. Let's go to Monday. System off of the Kurils and Kamchatka. 28, 29, it says 30-foot seas here, but yeah, there's maybe one little pixel of 30 foot there, but basically 28, 29-foot seas. That system traverses, makes it off to the date line, a little bit over the date line. Now remember, there's a trough right here, right? So it starts building a little bit, 20, 22, 24, let's say 25-foot seas. Falling south, look at that, pretty close to Hawaii, so every one of these, every 5 degrees north and south is 300 nautical miles, so 6. We'll say about 900 nautical miles from Hawaii, aimed right at Hawaii. So certainly, and then more fetch moving in on Thursday, and probably some energy from this will make it to the U.S. West Coast as well. Very probably west angle, so maybe even potentially Southern California could see something. Not any large size, not any long period, but something. New system. Also, Friday morning starts building off of the Kuril Islands with 46-foot seas. Oh, that's good, man. That's another long arc, great circle path into California, but less distance into Hawaii. Maybe some swell from that. Let's see, if it's on like Friday, Saturday, then maybe 3 days there, 5 days there, something like that. Just eyeballing this. And then pushing up to the north date line like all the others and pretty much fading away. Something trying to make it into the northern Gulf. Into the northern Gulf, but we'll see. The jet stream, we did notice the big ridge disappeared at 180 hours and flattened across. That maybe will open the northern Gulf a week from now or so. All right, local winds. We're not looking for wind swell here this time of year. If it was summer, we'd be desperate and say, yeah, for sure. But right now, we know there's swell coming. Enough for Hawaii and enough for California that we don't need to worry about groveling for wind swell. South winds, you can see it to the Golden Gate right about there, and pretty strong up in Cape Mendocino. South even down in Central California. Southern California, okay. Trades for the Hawaiian Islands. That was today. As we get into Monday, south winds building down into, say, Monterey Bay early in the morning time. Trades for Hawaii. And the front right there along the Golden Gate, something like that. As we get into Wednesday, the front pretty much dissipates. A light wind event along the California coast. Notice winds starting to trend southeast as this trough and the low starts building northwest of the Hawaiian Islands. So we get into Wednesday. You can see it there. There's the low. South winds for the Hawaiian Islands. The front probably right along in here. You can see the wind turning southwest off of Kauai right there. You know what's coming when the jet comes. And you also see high pressure building here in the center of the Gulf. We'll go into Thursday. Here comes your north winds for California. Hopefully not too bad. And your northwest winds also for the Hawaiian Islands by Thursday morning. It's pretty much over by then. Friday, winds lighten up for California. You almost get like a summertime pressure gradient here. High pressure here, low pressure inland. Produces a little fetch of 20-25 knot north winds here along the coast. Maybe some wind swell. And northeast winds raking the Hawaiian Islands. Not great conditions unless you're on the southerly shores. Get into Saturday here. Winds lighten up for California. That's a good thing for the weekend. High pressure here. Strong we'll call it northeast winds, 20 knots for the Hawaiian Islands. Through Saturday. Then we get into Sunday. Still the same thing. Maybe trades out on Kauai, but it has that northeast angle anywhere south of there. Light winds for California on Sunday. And that's it. We're into 24 hours out. So not ideal conditions for the Hawaiian Islands. But as we get close to Monday, it looks like maybe things will be improving. Not horrible for California, but not great. Precip. So we're looking at California. We did get a pretty decent amount of rain. Up in the Bay Area, we had, I think, an inch and a half in the rain gauge before the big rain event started. Dumped it out today. It was 5+ inches in there, so 4 inches of rain, let's say, over the whole event, which is pretty good. Sierra snowpack, quite good. I didn't really look to see what their base was, but they were at 70% of normal for this time of year, and there's more coming. Suspect there's going to be a bit of a break. 70% of normal at this time is not even normal, and if we hit a long dry stretch, that will, one, if temperatures go up, one, the density of it'll pack down, and two, if it's long enough that some of it actually evaporates, and then the whole time in a normal year, you're supposed to be accumulating snow, and if we don't get any that 70% could pretty quickly become 50%, and, well, we'll just see where we end up. But it's a La Nina year, so every drop we get is a gift. This big event, it was all of, 4 or 5 days or something like that in the central and northern California portion, and for Southern California, even shorter than that. It was all a gift, so we'll take it. All right, so let's get into Monday morning. Front building off the coast, trying rain for Cape Mendocino, but high and dry down south. And finally, on Monday night, the front approaches, makes it to the Golden Gate down into, Monterey Bay. Still no snow for even Tahoe yet until Tuesday morning. The first couple of flakes start falling. That time, the front looks like it's pretty weak. Yeah, rain along the coast on Tuesday, and by Tuesday night, it starts moving out. Though Central California has a little blob off there, and snow, not heavy snow, but snow continuing into Wednesday for Tahoe, moving down the Sierra, everything clearing out sometime by late Wednesday night. By Thursday, 1034 millibar high in control, things drying out, the wind machine starts, and things go dry, and we'll just run through this because you can see there's no blue, no precip anywhere near the California coast after that. Even the Pacific Northwest, pretty high and dry with this high pressure right here locking things down. All right, Squaw Valley snow forecast dashboard. The last little bit of snow forecast on Tuesday, we'll say, theoretically 25 inches. So we went and looked at the base at Squaw Valley. It's 84 inches with another, we'll say, 24. So we're at 108 inches. This model, when we looked at it right before the storm started, it said 108 inches for the whole event for Squaw. If we get the 2 feet that were forecast, the model will be right on track, which would be pretty good. we'll see whether that materializes or not. That was 84 inches of snow. I'm sorry, it was a 75-inch base with another 24 on top, so you're looking at right about 100 inches. This model said 108 right before, so a little bit overhyped, just slightly, but not too much. All right, and the base was 84 inches, so that's pretty good. That's good coverage. I mean, all the solid black diamonds at Squaw are open, you know, Headwall and Granite Chief, of course, KT and all that sort of thing. If you ever been up there in the summer and looked at the amount of boulders on some of those runs, you realize it takes a good amount of snow to cover all that stuff and make it safe for skiing. All right, so there's our snow temperature dashboard. All right, so freezing level is where the gray is sleet, the white is snow. So right now we'll say 7,000 feet, dropping on Tuesday night down to about 4,000 feet. But then notice after that, boom, big warm up to basically 11 to 12,000 foot freezing level, and then maybe sliding back down on the 10th of February. So warming up, no new snow, but a decent event on Tuesday. Let's go check Kirkwood. Kirkwood forecast to get about 22 inches, something like that, and they're a bit higher. Doesn't make any difference for the snow event. This is their base elevation. This is their summit. All of it basically in freezing conditions, and then the warm-up when it goes to 12,000 feet. No one's going to be spared from that. Let's go take a look at Mammoth real quick. And Mammoth, because they're further south in the front, this really isn't a strong system pushing south. Say 7 or 8 inches, 8 inches, something like that, and that's it. And freezing levels, again, here's the base of Mammoth. They're fine until you get the big warm up, but even at their summit of 11,000 feet, it's still going to be above freezing the whole way to the top. Maybe at the end of this, it'll be good the last little day there, maybe springtime skiing conditions for a day, and then once it gets the freezing level drops, everything's going to be bulletproof ice after that. All right, let's go take a look at long-term, what's going on with the Madden-Julian Oscillation and, of course, the El Nino Southern Oscillation. As usual, we like to look for the presence of the active phase of the MJO, and if you don't know, the MJO, Madden-Julian Oscillation, is this periodic weather oscillation. It travels around the planet on the equator from west to east, so from the Pacific, it moves from the West Pacific to the East Pacific. Takes about, 3 or 4 weeks, 5 weeks for the MJO when it's traversing the Pacific to make it from the west to the east. Then after it's gone, typically right behind it, the inactive phase does its thing over the same time, like 4 to 5 weeks to get across. Okay, the active phase is like low pressure. It actually helps feed storm production. It feeds energy up into the jet stream. And if the jet stream is stronger, that helps build storms, helps build precipitation. So when the MJO is south of California, California's at 120 west, when it's down here, it'll help usher in storms and weather. And of course, the inactive phase does the exact opposite. It brings high pressure to the Pacific, enhances trade winds, and kind of locks things down. So we're always looking for the presence of the active phase of the MJO. All right, so this is data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. The arrows are what we're looking at. These are 5-day average winds, and you see, and we're looking for the east-west component of the wind. The north-south doesn't matter, but you can see strong easterly winds here in the East Pacific, continuing over the Central Pacific, and then what we call the Kelvin wave generation area. When the active phase of the MJO is here, it can actually stomp on these winds, reverse the wind direction, create a Kelvin wave. It'll turn winds westerly, take warm water. See these oranges? These are warm water here. Take that warm water, start pushing it to the east, not on the surface, but under the equator, down about 150 meters. Ball of warm water will traverse the whole Pacific, erupt off of Ecuador. If you get successive active phases of the MJO, they can create successive Kelvin waves, and that is how you can usher in El Nino. We don't think that's going to happen anytime soon, though. But we are watching closely, not so much for the development of El Nino right now, but more for the demise of La Nina. All right, so it's not the actual winds, it's the anomalies. Differences from normal for this time of year. Yeah, we have strong easterly winds here. We see some arrows here, small arrows, so yeah, they're a little bit stronger than normal, but not much. Over the Central Pacific, totally normal. In the Kelvin wave generation area, these east winds are a little bit stronger here, but not so strong in the west. And the Kelvin wave generation area goes from 170 west, so just the east side of the date line, 5 degrees north and south of the equator. That's New Guinea right there. This is the far west Pacific here. So if you draw a box in your mind's eye right along in here, that's the Kelvin wave generation area. So you see easterly anomalies a little bit strong on the east side, but pretty normal over on the west side. So not a horrible pattern for the moment. All right, the forecast. Now, what are we looking at? Whole planet on one chart. We're just looking at the east-west component of the wind, not the north-south. If you see purples, blues, that means winds are stronger out of the east. If you see reds, yellows, stronger out of the east here. The reds are stronger out of the west. We want the west anomalies. But where are we? Okay, the date line's right there. It has to be in the Kelvin wave generation area. So the far west Pacific, the start of the Kelvin wave generation area, is roughly right along there. Go the whole way up there. And then the far east side is right about there. So, and here's where we are today. So here is the yellows, our westerly anomalies in the Kelvin wave generation area with a little bit of easterlies over on the far right-hand side here. And what are we supposed to get over starting tomorrow? And building easterly anomalies. Not particularly good. So also notice, but they're not nearly as strong as they were back in early January into mid-January. Now, these easterly anomalies typically stomp on the jet stream, but we think they were actually helping to feed the jet stream because La Nina was incredibly strong, Walker circulation changes, all this stuff. We're not going to get into it tonight. We could talk about it for an hour, but a very rare event occurred. The jet stream was nuking with easterly anomalies in the Kelvin wave generation area. It doesn't happen very often, but it did happen. Now we're back into this kind of weak pattern, and we don't foresee that any building of easterly anomalies are going to do anything for the jet stream. So nothing to really help, get rid of the split in the jet. If anything, it'll probably get worse as we get into here. All right, let's continue on. Let's go out, look out 2 weeks. This is outgoing long wave radiation, another component of the MJO, another way to read the signs of the MJO. OLR, fancy words for cloud cover. If you have blues, that means a lot of cloud cover. And cloud cover typically is associated with low pressure, which is typically associated with the active phase of the MJO. All right, so the equator runs right there. There's South America, Central America, Mexico, Hawaii right there, Australia, New Guinea, Philippines, Kelvin wave generation area right there. So the active phase of the MJO, it appears, is right where it needs to be right now. And per the statistic model, that's what this is going to stay there for the next 2 weeks. That's good. Also notice, though, an extremely strong inactive phase of the MJO over here in the Indian Ocean and moving over the maritime continent. That's Bali and this area right in here. All right, but there is also the statistic model. And we'll see, maybe we can do, there we go. We got both of them, the last frame. I'm sorry, the dynamic model. This was the statistic. This is the dynamic. It's pretty much saying the same thing. We look at the last frame here. Yeah, maybe the statistic says the active phase is a little bit stronger than the dynamic says it was. I think yesterday they were reversed, but either way, 2 weeks of the active phase of the MJO, that's good. We'll take it. That should at least help the jet stream a little bit. Continuing on, phase diagram charts. This is the statistic. This is the dynamic. What are we looking at? Well, this tells you how strong the MJO and exactly where it's located and the active phase of the MJO and exactly where it's going to go. All right, so what's this circle? Assume you're looking down on the North Pole, like here. You're looking down on it, and assume the circle is the North Pole. Or the equator, because it's really, you're looking out around the edges. And the MJO travels around the equator from the west-east, Indian Ocean to the maritime continent, West Pacific, East Pacific, under the United States, across the Atlantic, Gulf of Mexico, Atlantic, over North Africa back to the Indian Ocean. Where the heavy dot is where the active phase is, and the further it is away from this dot, the stronger it is. Whoever dreamed up this chart, I gotta say, they're a pretty smart cookie. It's a weird chart, but it works pretty well. It gives you a good idea once you get your head wrapped around what it's trying to tell you. All right, so the MJO is right here in the far western Pacific, and these are 3 different variations of where it could be, but by and large, the statistic model suggests it's supposed to stay somewhere in the West Pacific, but getting weaker over time. The dynamic model here says, well, it's supposed to stay in the West Pacific at moderate strength. The further away the dot is from the circle, the stronger it is. And that it's supposed to hold position for the next 2 weeks. This is the better outcome. This is the model that tends to be a little bit more accurate. We'll go with it. Next up, the upper level model. So this is just areas favorable for precipitation. Where the green is favorable for precip. Where the orange and yellow is not favorable. The green is the active phase of the MJO. The yellow, the inactive phase. All right, so what are we looking at? The equator is right there. Okay, there is South America, Central America, equator here, New Guinea, Australia, Philippines, Kelvin wave generation area right there. So the active phase of the MJO, more or less in the Kelvin wave generation area, and continuing to move east into Central America on about February 25th. So, 3 weeks from now, 4 weeks from now, something like that. With the inactive phase of the MJO building about mid-February, and it too making its way across the Pacific into the East Pacific by mid-March, with another weak active phase building behind that. The CFS model going out 1 month. All right, we can look a month into the future. Okay, Kelvin, the whole planet on one chart. Blues are easterly anomalies. The yellows and oranges or reds or whatever, westerly anomalies. The active phase of the MJO is typically associated with westerly anomalies. Here's where we are today, January 30th. The solid black contour is the active phase of the MJO. So this syncs up saying the active phase kind of thin and weak, but it's right over the Kelvin wave generation area. Sorry, Kelvin wave generation area starts there, 135 east to 170 west right there, with, mixed bag of westerly anomalies in the Kelvin wave generation area, but also notice these dotted purple lines. This is the high-pass filter. This is the El Nino La Nina filter. The dotted lines suggest are indicative of high pressure, which is another way of saying La Nina over the Kelvin wave generation area. So, yes, we have the active phase of the MJO, but it's really being stomped on by the La Nina base state and stealing all its energy, not doing a whole lot to promote storm production. But the good news on this is this high-pass filter, you see, it's 2 contour lines. That second contour line fades out about mid-February, and the final contour line is maybe 60% of what it was right now, suggesting the demise of La Nina. Also notice the solid purple contour here over in the Indian Ocean, which would be the El Nino indicator if it was in the Pacific, but it's in the Indian Ocean. It all but fades, theoretically, according to this version of the model, by mid-February as well. Now let's go look at the longer and more sensitive, believe it or not, CFS model. Again, whole planet on one chart. Kelvin wave generation area starts right here, goes right up the chart, and ends right over here. But the forecast is up top, not on the bottom. So here is this big bout of easterly winds. The blues are easterly anomalies that we had up until just recently, where things sort of mellowed out. But you see what's forecast here is much more easterly anomalies coming in the February time frame, and then maybe an active phase up here. Let's overlay the MJO, see if we can guess this right. Oh, so supposedly the active phase, here we go, the solid contour, is in play over the Kelvin wave generation area right now, mix of east and west anomalies, and it moves out of the Kelvin wave generation area, let's say, mid to late February. Big inactive phase sets up with strong east anomalies through into late March. This will probably be, if I were to guess, high pressure and nuking north winds along the California coast, but who knows? We'll see. Then theoretically, another active phase of the MJO setting up, late March, continuing into mid-April, and then another inactive phase and east winds after that. I mean, nothing great here. The active phases, this is typical La Nina. Active phases are very weak. The inactive phases are stronger. They have lots of east winds. It's when you get into El Nino, the flip side happens. The active phases are very strong. They're dominant. They just feed the storm track like mad. And the inactive phase of the MJO is very weak and incoherent. All right, let's overlay the low-pass filter. So this one's a little bit more sensitive. The dotted contour is the high-pressure bias. 1, 2, 3, 4 contour lines here, locking down the dateline region. This version of the model says the third contour line, or the fourth contour line, is supposed to die in April. I saw another version of it yesterday. It was like almost a month earlier. But even after that, 3 contour lines, no immediate demise of La Nina in the Pacific, according to this. The El Nino indicator here, the low pressure bias in the Indian Ocean, 2 contour lines, that second contour line dying in mid-February. Now, yesterday's run of the model had this line right here, this black line, like collapsing to be almost half the width that it is and starting to push off to the east. But this model it's having a really hard time, and actually most of the models do as you get into the springtime. We'll say late March into mid-June, early June, something like that. The models struggle mightily, and it's not till the atmosphere kind of figures out what it's going to do. If there were going to be a big transition, it can happen. We've seen it as early as like early February. Something flips and things go nuts. But that's only if you're moving towards a major El Nino event. Have we seen it? Most of the time, it's more like in the May, June time frame. You start getting some hints that something might happen, like a moderate El Nino or a moderate La Nina kind of thing. This year's La Nina started in April. I think we have that on a chart somewhere. It'll come up here in the presentation. All right, let's move on. All right, enough MJO discussion. Let's go talk El Nino, La Nina. Clearly La Nina. Let's look at the ocean. In the ocean, we're going to start at depth in the ocean. This is the West Pacific here, East Pacific here. These little X's, or these lines right here, are the anchor lines on the TAO buoys strung across the equator used for monitoring El Nino. The X's are sensors on the anchor lines. This data can all be collected, radioed up to Maryland, I think. They use a model, fill in the gaps, and you get a profile of the subsurface ocean temperatures. The idea being here is if you can actually monitor Kelvin waves going across the Pacific from the West Pacific to the East Pacific. All right, so the 28-degree isotherm is at 160, what is that, about 166 today. It was actually back here, so it suggests that warm water is building a little bit here. The 24-degree isotherm is, the good news is, I think last week it was very thin. The 24-degree isotherm is building, suggesting more warm water at the surface in this area. And if you're in a strong La Nina, that would not be the case. In fact, the 24-degree isotherm, most of this winter it's dead end. It just like plowed up and ended right here at 140 west. Now it's pushing into almost Ecuador. A sense that maybe things are returning somewhat back to normal. But it is not the actual temperatures, the anomalies, differences from normal for this time of year. You see 1, 2, 3 degree above normal temperature, all locked in the far West Pacific, typical of La Nina. All the warm water's here, all the cold water, minus 2 degrees centigrade, so that's what, 3 or 3.5 degrees, minus 3 degrees right there. So the East Pacific, colder than normal. This is no big surprise, this is what it's been all winter, but you do notice warmer than normal waters, 1 degree above normal, starting to build in the East Pacific. Again, a sign that La Nina is fading. The trades are returning to normal here. That some warm water, if the trades weaken, you have less upwelling, less churn, and then the sunlight beating down on the ocean surface can warm it up, and you start building a little bit of warm water. There's this other model here using the same raw data, suggests temperatures much warmer over here. What is this? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 4 to 5 degrees above normal here in the far west Pacific. No big surprise given all the preponderance of east winds that have been going on. Temperatures, cooler temperatures, milder than normal, but it doesn't show the warmer than normal temperatures here. It kind of hints at it, but it's having a trouble figuring it out. But we know for a fact they are there. Sea surface anomalies, the height of the ocean. This is not temperatures, the height of the ocean. This is from JSON 3 satellite data. It's a satellite rotates polar orbit around the planet, beams radar down, and it measures the how quickly the radar bounces off the ocean surface, returns to the satellite, and then can calculate to within a centimeter or so whether the ocean is higher or lower than normal. That is, they strip out the waves, strip out the wind waves, strip out even the tides, and is the ocean higher or lower than normal? Right here, 5 centimeters below normal. 10 centimeters here. So what am I looking at? Here's South America. That's Chile, Peru, the Galapagos right there. That's the equator. The date line's right there. Central America, Mexico, you get it. New Guinea right there. There's the equator. Below normal sea surface heights over this broad area here from Mexico out to the date line the whole way down to Chile. What that means is the ocean, of course, is lower than normal. And why is that? Well, 2 reasons. One, colder than normal temperatures cause water to contract, and that creates a divot on the ocean surface. And if you have strong easterly winds blowing water this way, then you get a divot here and a buildup over here, right? And you notice 25 centimeters above normal here. A lot of buildup. So the assumption is a lot of warmer than normal water here, cooler than normal water here. But the neat thing here is, look at this. We almost see, maybe we can pull the scale up here real quick. 0 to 5. So just almost neutral sea surface height starting to show up and thinning out in pockets just north of the equator. What was this, 10? So we're really interested in 5 degrees north and south of the equator here. The Nino 1.2 region is right in here. The official El Nino region is south of California, so from here out to 170 west, right in there. So still negative anomalies here, presumably colder than normal water underneath the surface. But some signs of return to normal here off of Ecuador. And here's sort of a history of what's been going on. West Pacific here, East Pacific here, April. You can see here was our last Kelvin wave, warmer than normal temperatures, moving from west to east, driven by the active phase of the MJO and westerly anomalies in the Kelvin wave generation area, which would be over in here. And then all of a sudden, easterly wind event, east anomalies, inactive phase of the MJO, colder than normal water temperatures. This is upper ocean heat anomaly. So this is not only at the surface, but down at depth in the ocean. A little bit of a pause back in July. And then La Nina raging, peaked out in right around Halloween. And you can see now, look at this. We're only, let me see if I can pull the scale up here. There you go. What is this? Yeah, it looks about somewhere in that range there. But temperatures definitely, and there's even little pockets here, and that's about it, of near normal temperatures starting to show up. Nothing great. We don't believe that, this could be very transitory, so we're not going to take it to the bank, but it seems like La Nina is losing some of its edge. And notice the amount of warm water building up in the West Pacific. Quickly moving to the surface here. So notice, here is Ecuador. This is Chile, Peru, Ecuador. The yellows, warmer than normal temperatures. These are anomalies, differences from normal for this time of year. There is warming developing the whole way out to about 135 west. Hawaii is still out here, so we're not south of Hawaii yet, but a definite warming trend in this area. Still cold water out here in the official El Nino monitoring region. Starts at 120, so it goes from about here and out a little bit past the chart. More cold than warm, but a step in the right direction. The 7-day trend, real quickly, Yellows, oranges, warming. Warming developing on the equator. A couple little pockets of cooling in there, but still, this has been going on for days now. Not quite as warm down here, but still a warming trend. That doesn't mean that the temperatures are warm. They're just not as cold as they were. But we know in fact, they actually are kind of, normal and a little warmer than normal right in here. So that's good news. And then again, the overview. You see little bits of warming here. Will it last? Who knows? All it takes is one inactive phase of the MJO and some easterly anomalies here, and all this will be gone in a nanosecond. But it suggests, at least for the moment, that La Nina is taking a break. All right, sea surface temperature anomaly history in the Nina 1.2 region. This is right there along Ecuador, the Galapagos. You can see where we were back in November. Temperatures 1 degree below normal. And just to let you know, the La Nina or El Nino is just a change of a half a degree. If you're warmer than normal for half a degree for 5 consecutive 3-month periods, you're in El Nino. If you're below normal for by half a degree for 5 consecutive 3-month periods, then you're in La Nina. We're besting that by some good. This is not the official El Nino monitoring region, but this is that area right there where we saw the warming. You can see the warming definitely occurring. We're in positive territory by 14.14 of a degree above normal. So no big deal. 0.14 of a degree, no big deal. But at least we're over the normal threshold for the first time in months and months. In the official El Nino monitoring region, that's the Nino 3.4 region, temperature is still negative, 0.75 of a degree, minus 0.788. But you can see a little hint of maybe a rising trend, but nothing significant, nothing to say we're out of the woods by any stretch of the imagination yet. And then finally, what's all this doing to the atmosphere, right? We're looking at all this stuff going on in the ocean, temperatures at depth, at the surface, trends, all that, but it has to manifest in the atmosphere. And the atmosphere, of course, sits on top of the ocean. They interact with one another. When they're both in a line, they are said to be coupled, and then they start reinforcing each other, a recursive loop, if you will. All right, so the Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. When pressure is higher in Tahiti, since Tahiti is in the Pacific, the index goes positive, and that suggests a La Nina, or at least the inactive phase of the MJO. Today's value, plus 6.18. No surprise. We were up at 30.25. You go back the past month, it's been positive for quite a while. No surprise there. 30-day average takes some of the noise out of it. We're down a little, 15.87. We were up at the 17s. Where were we last week? We were somewhere around here, 16.78. So actually, we're trending downwards. That suggests the atmosphere is not as predisposed to high pressure as it was, but we're sort of splitting hairs, because once you're in the 12, 15 range, you're in La Nina territory, and we are still quite there. The 90-day average, very much a lagging indicator, at least 2 months behind this one, but it too, at 13.74, clearly in La Nina territory. Yeah, we were at 14.3, and now we're down to 13.7, but that is not a trend. It's been rising steadily for 6 months or more. No big surprise, but we think we're past the peak. The 30-day moving average graphed out. We saw this last week. We thought we were at our peak right up here at around 20. We are starting to inch our way down, but so back in October 2019, see where we were, and it's just been this rocket ship steady upward. And each one of these upward spikes is the inactive phase of the MJO. The downward spikes are the active phase. You can clearly see the inactives are beating or besting the strength of the actives, so hence you move into La Nina. So now what we would want to see is a bunch of strong active phases pushing us to at least neutral. Don't think that's going to happen anytime soon. The ocean and the atmosphere are coupled, are fully engaged in the La Nina pattern, and they will not be decoupled easily until something dislodges them. Finally, the forecast from the CFS model for sea surface temperatures in the Niño 3.4 region, the official El Niño monitoring region. Today, we are at, according to this, about minus 3/4 of a degree below normal, clearly in La Nina territory, and forecast holding into about April. And I'll believe the model to here, but then it suggests this just off the cliff dive into oblivion and going back into a deep La Nina pattern by October. Not going to believe that. If it keeps saying that, maybe in June, then we'll pay attention. But for right now, we're in the spring unpredictability barrier. It runs right around in here, and that's right where this big turn is supposed to happen. So we're just going to have to wait and see. Other models are not on board at all. They say we're supposed to return to normal in the fall. Even at that, though, the atmosphere, even if the temperatures return to normal, the jet stream and upper level circulation over the entire planet has to reconfigure itself. We don't expect that to happen under the best of situations till November or December. And by then, your winter is it's not like you're going to just go into some powerful winter and everything's going to be great. No, it's going to next winter will probably be a weaker version of what we have this winter at best. So another dry winter, another not so great surf winter. Though we did have an epic 6-week run, but 6 weeks, it does not make a whole winter. We got, we still have quite a few months to go. So we'll see what happens. All right. So right now, hey, there's some waves in the water. Nothing great if you're in California and Hawaii. And there is more expected, but the problem is weather for both California and Hawaii. Hawaii actually probably will do worse than California because they got the jet just ripping right over them through pretty much the entirety of this next week. California will get our rain, we'll get a little bit more snow, maybe 2 feet up in the northern Sierra, and then things go high and dry for a while. Temperatures warm up, beautiful conditions. The question is, will we have surf by the time everything cleans up and looks nice? We'll see. If the jet stream dips a little, kind of does its thing, maybe we'll get some swell, north-angled swells, typical La Nina kind of thing, at least in central North California, Southern California. Pretty protected there. It's going to be hard to say. Hawaii, certainly there are storms forecast pushing off the Kuril Islands. There will be surf in the islands, and there'll be small, long period stuff coming into California from that as well. Long term, well, we're in La Nina. We're going to continue being in La Nina. Typically what happens during the springtime, high pressure sets up strong in the Gulf, nuking north winds. Yes, you get wind swell, but you get a lot of upwelling. It gets quite cold and quite miserable for a couple of months. So hopefully we don't end up there. We're not betting on that. We're actually kind of hoping more that we get some more rainstorms in here. The jet kind of dips further south and we get some more snowpack so that we can make it through the summer into next fall. All right, so that's it for this week. If you enjoyed the video, give us, where are we going? There, give us a thumbs up. Comments always welcome. We try to respond to every comment. We appreciate hearing what you have to say. And sometimes we get some pretty good discussions going on, theories about what's going on with the weather and et cetera, et cetera. So take a look. Subscribe. If you haven't subscribed, that's okay. You can always see the video, top page of every page in the stormsurf.com site. We link to the video so you can watch it there and you can follow along, use the wave models, weather models, all the El Nino tools, all that stuff on stormsurf.com. And then that's it. You'll a little bit at a time, you watch the video, you follow along during the week, and you get more in tune, especially if you're going surfing, and sort of compare what you see in the ocean with what you see on the charts. And pretty soon you are your own surf forecaster, and then you don't need us anymore. All right, so that's it. We'll see you again next week, same time, same channel. Stay safe, and we'll see you then. Bye-bye.